Okay, welcome back everyone. Today we're looking at chapter 13C, example 8, and that's going to be solving equations in the form of sine ax plus b is equal to c. You can see down below I have an example here with a very similar type of format to the one above. The process for these type of questions is all going to stay pretty much the exact same. And that is going to be step 1 is to let my angle that I have here, let this angle in my brackets equal theta. So I'm just going to write it out again. So sine 2x plus pi on 3 is equal to 1/2. Once I've got that part there, now I'm going to let theta equal my angle, which is 2x plus pi on 3, which gives me a much simpler equation like so. Now, some of us might be thinking of our exact values and might already be thinking about, theta or sine theta equaling 1/2 is going to be true when theta equals 30 degrees or pi on 6, which is great. However, there's a little bit more to this type of problem. You can see here, I've been given a domain, which is saying that x is between 0 and 2 pi. And in fact, I might write that in interval notation because I find it might be a little bit easier for this idea to look at it with intervals. Okay, so there's our interval notation. It's x is between 0 and 2 pi. Okay, so if I put this in interval notation, I can see that I have x between 0 and 2 pi. Now, I did make a substitution here where I said, hey, let's let theta equal 2x. Let's let theta equal 2x plus pi on 3, which means I also need to kind of balance out my boundary conditions I have over here on my right-hand side if my equation is going to be given in this form. So if theta is equal to 2x plus pi on 3, let's start with the 2x bit. If I make this part here 2x, then I have to multiply this x is going to become 2x. So I multiply everything through by 2. 0 times 2 is just going to give 0. And 2 times 2 pi is going to become 4 pi. The final bit I need to do to edit my domain is to add my pi on 3. So 0 plus pi on 3 is just going to give pi on 3. And then 2x plus pi on 3 in the middle. And then it's going to be 4 pi plus pi on 3. So all I'm doing is I'm essentially applying transformations. You can see x is multiplied by 2. So I multiply everything by 2. And I've also added in pi on 3. So I'm going to add in pi on 3 in here. And I'm just balancing across my sides. So that means now when I have a look at trying to solve for my equation, sine theta is equal to 1/2. I know that one of my values for theta is going to be pi on 6. That's just based on my triangle. Sine of pi on 6 is equal to 1/2. If I look at this in the context of my unit circle, here you can see if I draw myself a set of axes, if I think about pi on 6, then if it's sine, there's 2 places where that's positive. It's going to be positive in quadrant 1, and it's also going to be positive in quadrant 2 if I draw it like so, which means this angle here is going to be pi on 6. This angle here is going to be pi on 6, which means if I take my whole angle, because I always take my angle from this part of my Cartesian plane, then this angle here is going to be pi minus pi on 6, which is going to equal 5 pi on 6. So right now I've kind of figured out 2 solutions. I have pi on 6, I have 5 pi on 6. However, I'm going between these boundary conditions over here. So I'm going between pi on 3 all the way to 4 pi plus pi on 3. And in actual fact, let's simplify down my domain just a little bit more to make this slightly easier to read. So I have pi on 3, that part's going to stay the same. And now if I simplify this right-hand side of 2x plus pi on 3, now if I simplify my right-hand side, 4 pi plus pi on 3, that's going to equal 13 pi on 3. So I now basically want to figure out how many angles I have that are going to go around in my circle. If I have a look already, I can see that pi on 6 actually is smaller than pi on 3. So this here won't even be true at the beginning. So my first angle is going to be 5 pi on 6. Now, if I kind of keep working my way around the circle, really we just have to kind of think about this as we kind of rotate around. A few little simple-ish tricks to help kind of think things through is to convert my fractions into like mixed numbers. So this 13 pi on 3 can simplify down to give 4 pi and then pi on 3, which means I know every 2 pi is 1 full rotation. So it's going to go around the circle 2 times fully and then another pi on 3 past that. So if and again, we're starting from pi on 3 in this case, which eliminated my pi on 6. Okay, so if this here is just to help keep track of my cycles around the circle. So I'm starting here at 0, and I go past pi on 6, but that's before pi on 3, so it doesn't count. So now I'm going to go all the way around. I hit 5 pi on 6 over here, which you've already got written down. I come all the way back around to 2 pi. Now I come another pi on 6. So that's going to be 2 pi plus pi on 6 is going to give me value 2. I come all the way back around to pi on 6 again, and then I complete my second full rotation. I'm going pi on 3 past this, which means I'm also going to include this pi on 6 as well. Just to help kind of make it clear, obviously we're going to have to do this in our minds a little bit, kind of count it through or think it through, but it means I should have 4 values because I'm going to have 5 pi on 6, come around once, have another 2, come around again and have 1 more. So that's going to become 2 pi plus pi on 6. Comma, it's going to be 3 pi minus pi on 6 because this could be pi, but if I go around again, it's going to be 3 pi at this line, and this is going to be 2 pi and 4 pi if I do a second rotation. And my final value is going to be 4 pi plus pi on 6. So I'm going to give myself a little bit of space and simplify down that line of working. Okay, I move my picture across the side here. Let's simplify all of this. Theta is going to equal 5 pi on 6, comma, that's going to be 13 pi on 6, 17 pi on 6, and 25 pi on 6. So they're going to be my 4 values, which makes sense. Again, if I'm counting through my rotations, I should get 4 solutions. However, I'm not quite done yet because theta is actually equal to, if you come back to the beginning, 2x plus pi on 3, which means 2x plus pi on 3 is going to be equal to, let's just start with the first one, 5 pi on 6. Now I'm going to just simply do some algebra rearranging. I'm going to have to do this 4 times. So I might just do 1 and then I'll put the answers up. I'll let you guys work through the rest and you can just kind of check whilst you're watching along to make sure this all makes sense. So if I subtract pi on 3 of both sides, I get 2x is equal to 5 pi on 6 minus pi on 3. If I just change the denominators to both be over 6, it's kind of like 2 pi on 6. So I'm going to wind up with 2x is equal to 3 pi on 6, which means that that's going to simplify down to equal pi on 2, which means x is going to equal pi on 4 when I divide both sides by 2. Like I said, I'm going to put the answers up to the rest of them. Ta-da, that's the last 3. Again, it's the exact same process. 2x plus pi on 3 equals 13 pi on 6. It'll equal 17 pi on 6, and it will equal 25 pi on 6. And then just rearrange and manipulate your algebra. Okay, hopefully that was helpful. Like I said, this is how to solve any equation that's in the form of sine ax plus b. Really, the main idea here is understanding how to manipulate my domains. So this part here really is the key to getting our values right. Then it's just a little bit of visualization, or you can think it through, draw a few pictures, take your time and get these 4, 5, 6, 7, however many values that you need.